In this video, I'll discuss the behavioral design color system. This is a mission critical video where I'll cover the technical details of the system. We won't get into specific applications yet. The point of this video is to help you understand the suite of color spaces, tools, and resources that I'll be using throughout the entire course. And this will help you understand the lessons, it will help you understand the applications, and how to connect the theory into practice. So, that sounds like a good starting point. Let's roll. You know, Dostoevsky once said, the best way to keep a prisoner from escaping is to make sure he never knows he's in a prison. And this quote pretty much sums up how I feel about the color systems that we use in technology. You see, here's the problem. sRGB, the dominant color standard in technology, is not human-centered. sRGB makes assumptions about how people perceive the world, which are wrong. This causes all sorts of problems the moment you try to use it to teach color psychology, and it constantly sabotages your work when you try to apply color psychology. There's a very good reason why psychologists and neuroscientists who study color and the brain do not use sRGB. Instead, they use a variety of CIE-based color systems and different ways of calibrating their technology. And I have to make a big confession here. I actually struggled for years to teach this subject, and you wouldn't believe why. Basically, the diagrams that you use for teaching this subject were all designed by different engineers and scientists based on different assumptions and different applications of color using different systems. And so what happens is the moment you try and piece them together to teach your students, you're left with this insane mess of different diagrams based on different logic. And guess what? They do not fit together and they create a big confusing mess. What makes more sense is to have intuitive color systems that help students connect the dots instantly. The current situation for students is pure torture. And for a lot of teachers, this situation sort of sucks. Now, for myself, how can I teach this subject when most of the teaching aids are an incompatible mess? And how can I teach the psychology of color when the technology that we use to express colors are not human-centered? I tell you how. I use something a little bit crazy. I built an entire color system from the ground up. I use perceptually balanced colors aligned with scientific standards for measuring color in the brain, and I tied them all to legacy color systems that we use in today's technology. And in this class, I'm going to use the system to discuss color strategies, to cover psychological principles, and to walk you through the emotion behavior model. And may I present to you the behavioral design color system. So, what's the behavioral design color system? Simply, it's a selection of CIE LCH colors that reasonably fit human perception with the least distortion when expressed through sRGB. You can think of it as a bit of a balancing act between the types of systems that psychologists use for studying color in the mind and what we can reasonably use in technology. It's comprised of 5 main components. So color spaces, color scales, research and teaching tools, design resources, and practical applications. And what I'll do next is I'm going to go through each of those in detail.
We're going to start off with number 1, color spaces.
The first thing we need to consider in the system is the full spectrum of colors that humans can perceive. And typically this is used by the CIE XYZ. sRGB, the system that we use in technology, is one of the most narrow systems available. There are others like Adobe, Profoto, but unfortunately, they did not win the proprietary wars. For the behavioral design color system, I took a sample from a system called the CIE LCH. This system provides a systematic way to select colors that represent how humans perceive the world in a way that we can reasonably represent within technology. Now, I had to do a lot of agonizing work to find a selection of sRGB colors that reasonably fit. To show you how much distortion has happened, I have the CIE LCH on the left and the sRGB colors on the right. And you can see where I selected them on the left and what I got. based on what was available within the gamut of colors in sRGB. There's a lot of distortion in the system that we're using, but there are no good options on the table. So you can think of the color space that we'll be using as the least crappy option or the best that we can do under the circumstances. The rest of the system builds on this.
Number 2, color scales.
Before I explain the scales, I need to describe a very important distinction that many people do not make. And that's between the two types of visual color processing, trichromatic and opponent process color processing. Most people have been told a very simplistic story, which is inappropriate for applied color psychology. And that story is that the eyes only process color through red, green, and blue cones, otherwise referred to as short, medium, and long wavelengths. Now, what's left out is that there's a secondary process called the opponent process color system, where those red, green, and blue light-sensitive nerves are actually mapped to 3 channels: a red-green channel, a blue-yellow channel, and a grayscale channel. This is very important because you see the trichromatic system is useful in some applications of color psychology, but the opponent process model has proven recently, just in the last couple of years anyways, to be the key to unlocking how we build algorithms that can read people's emotions and their physiological states. Now let's look at the 3 categories of scales that we'll be using throughout the system. The first is the brightness scale, where we look at colors and light in terms of their range from dark to white, or otherwise known as no light or no energy to maximum light and maximum energy. This gives us a perspective on human visual processing in terms of our rods or our grayscale or black and white color perception. Next, we have the color temperature scale. This is perhaps one of the most important scales for understanding color and human psychology, because this is the type of color that represents our experience of sunlight. This is the type of color that the entire planet and ecosystem has evolved with over the last 3.7 billion years. We are hardwired to respond to this range of colors, and the color temperature scale is going to be mission critical for understanding psychology and color systems. Finally, we have the color spectrum. So this is what most people think of when they think about color psychology. However, I had to make things a little bit more complex than I wanted to. So we're using both the trichromatic and opponent process color systems because the science is showing that both are relevant, and there are points where we might want to use one versus the other. There are also 2 ways that we can divide up the color spectrum. One is as a linear and the other is a circular perspective. To make the system more intuitive, I've structured it so that higher energy or more salience generally goes to the top or moves to the right. And I've made sure that all diagrams follow this exact pattern so that from diagram to diagram and tool to tool, the system will be very easy to follow. However, the concept of energy is a little bit messy here, so let me just explain it. In the brightness scale, energy of light goes up from black, which represents no energy or no light, to white, which represents light that's overloading our visual system. In the color temperature scale, energy is defined by heat, going from lower temperatures at the bottom to higher temperature at the top. And it also represents the type of light that comes off the sun, which we use in circadian design. Finally, the concept of energy is more complex in the hue or color spectrum, and that's because there's technically higher energy light at the bottom. However, the quality of light at the top from the warm colors up, so going from yellow, orange into red, that type of light actually penetrates deeper into our skin and warms our water more. So we experience it as conveying more energy because it's physically warmer for us humans just because of how the biology works. So technically, that's a more energized light from our human perspective. We will also be using these scales to understand light from a celestial perspective because we have evolved under the sun, and many of the effects of color and psychology are based on our relationship to the sun and also how our entire ecosystem adapts to the sun through changing seasons, through shifts in color in plants, and even changes in our atmosphere.
Number 3, research and teaching tools.
In this section, I'll introduce you to the main tools that we're going to be using. The first and the most popular is the color psychology map. And with this version, we have the black to white spectrum at the bottom and then the hue spectrum at the top. What you'll see is that in the hue part, there's 2 danger zones. The circadian zone, so that's an area where your designs will shift the minute people turn on blue blocking software applications, or if you're working and designing for human health, that's where you're going to want to be extra careful because you can rewind a person's circadian rhythms accidentally by exposing them to light at that spectrum at the wrong time of day. Next, we have the areas of color vision impairment, and those range in from around green to the upper reds. And of course, there are different types of color vision impairment, but the idea is that in a certain percentage of your users, they're going to have a harder time contrasting colors in those areas, and especially adjacent colors. There are both dark and bright mode editions of the color psychology maps. Now, obviously, one weakness of the system is we can't represent the brightness or the saturation. We do have tools for those, and one of them is a brightness variation, as we have here, which shows you how we can analyze United Nations logo colors based on the color blue and how bright they are. This version is excellent for research and doing color audits. And of course, there's a circadian color temperature map, which we use in a similar way, but this time to map the psychology of color based on color temperature and how it changes throughout the day. This tool is key for designing ambient lighting technologies, but also for designing adaptive template systems and interfaces that move with the light of the sun. Perhaps the most useful application is once we've mapped out our UI, we can then look at it in terms of digital eye strain, circadian disruption, visual impairments. There's also a suite of research tools that you can use for carrying out color research, whether it's in the area of psychology, visual design, user experience design, product design, that will allow you to get many orders of magnitude closer to scientific grade research while still staying within the realm of sRGB, which represents where most of your users are going to operate. Here are some of the tools that we're going to use. So the first is a one-dimensional hue scale. Really simple here, where your users are going to give you feedback from one end of the spectrum to the other. We have another multi-dimensional version. This version represents the major factors in color psychology that matter, and many of the pop psychologists have unfortunately highly misinformed the public because factors like brightness and saturation are far more important, and this single tool represents hue, brightness, and saturation all at once.
Number 4 and 5, design resources and practical applications.
You can use each of the maps as design tools. I've used the color psychology map in various projects. It can be a real lifesaver when dealing with large and complex projects. A few years back in my company UltraSpark, we took on a job to help a government of Dubai ministry redesign their website, their API, their database systems, their mobile system. Behavioral science was one of our major areas of speciality, but we were just as equally dealing with accessibility, and accessibility at the highest possible standard. Real-world implementations of psychology-inspired design is normally an artful implementation that requires multiple competing demands to be traded off against each other and balanced into an optimal solution that is as reasonably good as you can get under the conditions. As well, the system includes a suite of color palettes. There's a full template system, there's a data visualization system, and a semantic color system. Well, that's a wrap. We're going to spend the next while putting the system into use. We'll be using it for all sorts of applications. And if any part of this lesson didn't make sense, or there's certain jargon or terms you didn't understand or you don't know, don't worry. We're going to go through it later and you will understand everything. The main thing is that you at least understand the suite of tools that we'll be using so that it'll just sort of fall into place a little bit more intuitively once we hit the lessons where we're putting into use. One last message. This is the first time I'm publicly releasing this on a much wider scale. If you put it into any interesting applications and you have some stories to share with me about how you're using it, let me know. I'm always on the lookout for new examples, and we'll see you in the next one. If you found this video helpful, I'd appreciate a thumbs up. It really helps with my free teaching. If you're new here, this video is part of my color psychology series, which you'll find in my playlist. And hit subscribe for my latest updates on using psychology in digital products. See you in the next one.